Hello, good afternoon, everyone. This is Rahul Bagadia, Managing Director and Partner P Manifold. I welcome you all for this live demo session today. We will be discussing about electric vehicle systems engineering. This is a professional certification program that P Manifold is providing, and we have jointly partnered with Automotive Skills Development Council, ASDC. ASDC is highest skilling automotive skilling body in country, and we are glad to have them as partner for this program. Uh, this demo session is basically organized with the objective to help a prospective learner who is really evaluating, is this course useful for him, what benefits he could get from the course. So those are the kind of questions that we want to discuss, and we want to try our best to answer during this session. The, the program will be starting from coming Monday, 17th. So I think we really want to ensure that whoever is really keen for this course, they have all the information to take their decisions and move forward. Uh, I am happy to kind of go through my slides, but I thought that it will be useful to really understand who you are and what kind of questions you would have that you are looking to get answers during this today's discussion. I am asking my colleague to kind of give you mute unmute control, and you can speak on your side and just introduce yourself and share some of the thoughts, first thoughts, like when you got to know about this course, how do you see this course, and what are some of the early questions that comes to you. I think that will give me a very good background in terms of understanding like what I can focus during this discussion. Let's try this out, and you are also welcome to just type in your chat window. You can share us your questions. Let's start with that, and then I will go through how we plan to organize this course, what will be our teaching style, what are some of the prerequisites, if any, that we are expecting from our participants, serious participants. Swapnil, can you please allow participants to speak and start with their questions?
Yes.
Are there questions that people who have joined this session want to at least share their questions before the beginning, or you would prefer to discuss it after I finish this demo session? Okay, no worries. So I think we will go with our conventional method. Let me discuss about this course and how we want to do it, and then we can take questions from you. So let's try to understand like what systems engineering is. Many of you would know electric vehicles. What are electric vehicles? What are the future of electric vehicles? When you compare electric vehicles with our conventional petrol or diesel vehicle, from simple engineering, we know that the thermal efficiency of a fossil fuel engine is quite low. Actually, you get hardly 20% of the power in terms of the energy that goes into the vehicle, while an electric vehicle you get almost 85 to 90%. So I think there is a fundamental improvement in the energy that you put into electric vehicle and its conversion to the mechanical power that allows you to move. So the future definitely is of electric vehicles. We do understand and we do hear a lot of views around the issues with range, issues with charging time. Countries outside India really adopting EVs faster. India is still trying to catch up. So between all those questions, so far in last 1 month since we have announced this course, we have different kind of people from all different varied backgrounds, and we believe that this course is really useful for one, product engineers who are already working in the automotive OEMs. These OEMs can be either conventional IC vehicles manufacturer, any kind, be two-wheeler, three-wheeler, four-wheeler buses, and you can be an engineer in the entire value chain of the OEM, right from the design to product prototyping to testing to calibrations to integration. So all for these roles of people, this project will still be very useful. You would be a domain expert in some aspects of IC vehicles or EV vehicles. This project will actually help you to really integrate different subsystems together and really understand how do they interact, and really understand it by your own models that you will be building it in Excel and Scilab. So that is what we are meaning by systems engineering. I'm showing you a very conventional V diagram, which is used in all global automotive players. And on the left side of this V, you see like the specifications which are set for the vehicle, right? You start with like what a consumer wants, then you come up with like what are your vehicle targets, and then you come down into further defining your subsystem targets, and from there you define your and you go for planning and selection of your different components, right? And once you have made the selections of your components and you're sure that it is at least in design and planning it is helping meet the vehicle targets, then you put the entire hardware software together and start doing your subsystem and vehicle validation, right? And the end output of all the integration of your vehicle prototyping is then going for the homologation, what you also call it type testing. And then finally the vehicle is delivered and then it goes into the full fledged of the production. So this is a very conventional vehicle development process. And you see that they are quite interrelated, right? And one option is to really do this through hard prototyping and then find out something change, and then you spend a lot of time in doing the, and also the costs, time and cost for doing the prototyping and taking. And simulations, what we also call virtual designing, it allows you to really do as many design trade-offs that you want to do before you take final prototyping. So this actually allows you to really speed up your entire process of design and development. And why it becomes more applicable, why EVs are more complex over the IC vehicles. EVs are different. Uh, they are, of course, it simplifies in terms of number of components in the vehicles, but these components are getting more and more electronics, and they are coming from all different suppliers in the value chain, right? And that increases further the complexity. And even specifying those specifications and holding your contract very strong with those players, you would need lot of understanding of how do you define your system specs, right? And how do you then test those system specs to give you the vehicle targets. So this course will allow you to go to that level of detail into each of the subsystems, right? And really test its performance upfront, and then integrate all these subsystem models like battery model, the motor model, the charger model, the other power electronics model. So you will be looking into each of these different aspects, building your own models, and then towards the end of the course, you will be integrating all these models into a full-fledged EV model. So that will become your simulation model. And now you can change different inputs, right? You can test your vehicle under different road and driving conditions, under different loading conditions. You can do different driving cycles of the road conditions. You can do different weather patterns to understand like how it is impacting your battery performance and what trade-offs with the range. So all this combination of test you will yourself be able to do towards the end of this course. Let's take an example of this thing. Here we are talking of starting with the vehicle requirements, right? Like as a user, what an end user wants, right? He wants a good peak power, like he can accelerate the vehicle faster when required. He wants a faster charging, and he wants a good range. So these are the typical requirements of a user. And how does this requirements translates into motor requirements and specifications, and how does it translates to battery pack specifications, is what this course will allow us to ask right questions and then build basic models and then understand the trade-offs and then make appropriate selection, and towards then integrate all of these things to really test the overall EV performance. Let's understand it little better with one more example. Also, to tell you, like there are two instructors for this program. The primary instructor will be my colleague and senior partner Vikrant Vaidya. He is unable to make time today. And Vikrant has last 20 years background in automotive systems engineering, doing all modelings primarily on the cars, and he has worked globally with different organizations, with different hybrids, with different pure electric vehicles, and doing this for last 20 years. He has designed this particular course, understanding the need of the engineer. He also has been recruiter for last 15 years from all the top colleges globally and in India, and he also understand like what are the gaps coming from the fresh students, and even these gaps existing with the existing automotive engineers. So keeping all those practicalities in mind, this course has been designed. So this particular example that I wanted to take is like typical requirements are like we start from the customer point of view, and typically a customer, as I said, like he wants a car going faster, faster than competition, and with good range, right? You usually start with this definition, and this definition then you further go into defining and quantifying it through doing benchmarks. And let's say you want 0 to 60 kilometer per hour speed in 9 seconds, and you want a range minimum of 120 kilometers with 10% DOD and 90% charge. So this is the vehicle spec at a very top level that you want your car to be delivering. And then you again benchmark like, is there any change that you want? Like you want to be best in the target segment, better than the target segments. How have you benchmarked? What cost point? What segment you are really targeting with your vehicle? All those choices will really help you make a call like where you want to position your model. And with this specification, then you need to go into the subsystem specs, right? So the second question will come like, what will be your wheel torque? For you to deliver this speed and range, what would be your wheel torque? What would be your battery capacity that you should be looking at? And then when you answer that question, the second level further will go into detailing of the motor torques, the gear ratio, how you really fit your pack in the space you have, what kind of series and parallel combinations you will do. So this is one example how from customer specs we go to the end mile of the component specs. Let's go a little deeper into it, like what you will start learning during this course. So Don't get scared with this model. We will actually help you to really understand different elements of this model. So this is a broad vehicle dynamics model, a 1D model that has been put. Through the course, you will actually be building small subsystems model first. And towards the end, you will be applying those different subsystem models applied to your vehicle model. And then you will be able to do some queries and some of these things. Whole idea would be like how physically you start understanding these numbers and not just charts things. So here, like after doing this model and some basic analysis, we find out that to achieve a 0 to 60 kilometer per hour speed under 8 seconds, you will need a wheel torque of 810 Newton meters. So this gets derived after you have the vehicle model and other parts. Now the second level of question would be like for this wheel torque to come, what is the range that you are looking at? So here like we have used the new European driving cycle, and under a short cycle that we have assumed, we found that you will need a battery capacity of 14.35 kilowatt hours, right? So again, all this was done using basic models, basic engineering functional models, and be able to arrive at like, okay, you need to cover this distance with this battery capacity and SOC, and this will be the battery capacity that will be required. So this is what you will yourself be able to do and understand and for your own application. So as part of the way the course is designed, Monday, Wednesday, and Friday, evening 6 to 7:30 p.m., we will have the theory sessions. When I say theory, there will be lot of physical and easy explanation of these different subsystems supported by such kind of models and understandings behind it, and there will be some assignments that will be given based upon this theory sessions. And Saturday, for this is the 5 weeks course, so for 4 Saturdays we will be meeting from 2 to 4 p.m., and this is the time where you will actually be pre-hand, you will be doing some assignments, some modeling things which you will be kind of oriented and introduced to. But Saturday is more kind of where we will be sharing the results and understanding what challenges, what inferences you were able to draw from your models, and also help you even one-to-one in terms of really solving any of the challenge if you have found in terms of building your models. So it's a very hands-on model, so that by the end of the course you actually start understanding like what are the critical elements. And if you are already part of a EV or an automotive OEM team, you will actually be able to rightly scope the part which you are trying to develop or contribute to your company with a much better and refined understanding. And post this first course, we will also be going with much deeper course. So the second course which we are already working upon is battery. So there we are in this course also you will learn about battery modeling, but that will be at a functional level. The second deep course that will be offering in battery, that will go into a much deeper parts of the battery, including electrochemical analysis and other part. How do we model and how do we kind of start envisaging some of the challenges that can come in terms of putting up the BMS and its application to the EVs part. So I just complete that same example with which we started off. We started with this question like what will be the Newton meter, what will be the kWh, and in the last slide we built the answers, and then we start facing some of the trade-offs. I will discuss this trade-offs. What are the trade-offs? So the first, when we start picking up the motor, then you have to choose like how you have positioned the vehicle and what really you want to do. So like for the wheel torque and the gear ratio possible, you have an option of a motor giving this motor torque 42.8 kilowatts, but then the speed limit, the vehicle maximum speed gets limited to 102 kilometers per hour. On the other side, if you want a higher speed and max speed of 134 kilometers per hour, but then you would require a much higher wheel torque, sorry, much lower wheel torque, and not the one that we started off with. So this is the trade-off that we'll be doing. Again, these are some of the diagram charts which will form inputs coming from the real characteristics of the motors. We will provide you this. We will also help you understand what it means so that this becomes an input into the models that you will be building together with us. The second trade-off is now the battery sizing. We already discussed about the battery sizing earlier, but this is one simple example that we want you to understand, like how what combination in series and parallel of a lithium cell you will be able to design the batteries. So here we have taken two examples, 120 cells in series and 45 in parallel, and this gives you a 50 kWh battery pack. It's a big battery pack for a car, which will give you much high range, and it also gives you a good peak power, right? But if you're really looking for a high peak power, high acceleration car, but you also want to optimize in terms of the cost, and you are looking for a smaller battery size for these reasons, then this range, but then your peak power gets limited. So again, as a designer of this vehicle and how you again want to position this vehicle in the market, you have to really take a right call, like what you want to do with this vehicle and what you cannot do in the budget and in the specs you are targeting. So as I said, like we'll be using two softwares during this 5 weeks program. One will be using Excel. Most of participants and people, we believe, have this model, have this software available. And if it's not Microsoft Excel, you can have any open source Excel as well. So Excel will be one tool which we'll be using during this program. And second is Scilab. Most of the automotive OEMs globally are already using MATLAB and very recently also Scilab. Scilab has all those capabilities as MATLAB. It's an open source free license tool, and that was the reason of selecting for this program, so that without licensing issues, our participants and learners are able to download this software and work closely with us. So we have built our Scilab models and library to use during this program. And it's a very I think, like if you are already a MATLAB user, this will be a very similar or simpler transition for you to use Scilab as part of this course. If you have your own reservations and you want to stick using MATLAB, that is also okay. As we said, it's fairly one-to-one modeling what we'll be supporting, but we can support if you want to pursue it in MATLAB, so that is okay. But for the others who are using it first time, we will be using Scilab into the program, and it has the very similar kind of a text user interface, and the Simulink here in MATLAB is called Xcos, but again very similar. So this is a tool, and it's a very strong and powerful systems engineering tool. The systems engineering is about thinking holistically. You are not thinking of just battery or range. You are not thinking of just motor or power. You may be a very good designer of battery or motors, but if you really want to sell it, what a customer is buying is the entire EV, that experience, that performance. So how do you really bring all these individual good components together in the budget that you have laid with all the constraints and engineering, and really deliver a very high quality world class product? So that is about the systems engineering perspective. Just a week back, we did a national discussion on this topic, EV skills in India, with participation from ASTC, CM, ACMA, Ather chief engineer, earlier Maruti chief engineer, and now with Ola Electric. and all of them unanimously agreed that systems engineering is a rare skill and that is highly missing. And it's missing not only with the freshers who are coming into the industry, the idea and the skills are missing even in most of the established and very expert engineers with the automotives. They are good in one component, but when they have to deliver upon as a entire system, entire model, that's where the issue starts emerging. And this is the skill that we want you to think through. And what best way if it can be think through from very physics, the mathematics part of it, and doing it in a fun form in Excel, Scilab slash MATLAB. So this is what the course will be really focused upon. We are starting the batch on 17th August, the coming Monday. So that leaves today being Thursday. Next 3 days, I would encourage that if you figure out, if you believe that this skills, which is a very unique skills of understanding any engineering subsystems or system at a very holistic level and be able to model, you are welcome to join this batch. Here we have indicated some of the learnings that you could expect from this program. I already talked about our certification partner ASTC. At the end of the, so yes, this is a very serious course. While it is a 35 hours of training sessions in theory and practical that we will be organizing, it is expected that you are able to give some time actually making these models and coming prepared for your practical sessions on Saturday. And basis to it, there will be two assessments. One will be a midterm assessment and another will be towards the end of the program. So combining all things put together, there will be a certification that will be issued joint with P Manifold and ASTC. Regarding trainers, I already talked about you. Vikrant will be the principal trainer, and he brings 20 years of automotive design, model-based design experience, and he'll be very happy to kind of discuss. For corporates, we encourage you to also bring some of your problem statement within company as work that you are kind of looking into it. And myself and Vikrant, we will work with you and your group to really see like if we can either that full scope, but we will help you with the right scoping relevant to this program and see like if by the end of this course you are able to solve a part of that problem statement or a much bigger part of that problem. So that is a benefit for corporates to really encourage their engineers to join us in group and have your own problem statement, which we will work together with you as part of a project during this session. And I already spoke about very hands-on program. It's not just giving gyan or theory sessions. And we also expect serious learners who are able to make time just beyond the theory sessions to be actually able to do the modeling. The whole idea, the whole idea is that you actually practice it by hand and be able to convert it into the learnings for yourself. And for that, we encourage you that you make time to do that modeling. Yeah. And in terms of time, I already talked. We have planned it for Monday, Wednesday, Friday, evening 6 to 7:30, Saturday 2 to Saturday, yeah, 2 to 4 p.m. And the idea of doing this time was that for students, professionals, and also working people, you are able to make time after work. Yes, we are asking some time over a weekend, but just to give you a relaxed full Saturday, we thought that we will do it in an afternoon because we are trying to pack a very high valued content in 5 weeks, and that was the reason of also using Saturday for practical sessions. This is a 5 weeks, 33 hours course. Eligibility of the course. This we are getting quite bit of questions. If you are studying engineering and you have some exposure to Excel and Scilab, maybe at a very basic level, uh, this course we will take you to the next level. And if you are an automotive OEM engineer, you are welcome. If you are a consultant uh, practicing and doing projects in e-mobility, this course will allow you to understand the basic engineering inside the EVs and be able to connect and envelop improved level of modeling on energy requirements, charging requirements, range impact, and all those kind of analytics. If you come from an IT company or analytics company who is looking to build any kind of value added services or products for EVs, this this training will actually allow you to really understand those elements and their interrelations, which you can then really try to capture to kind of build right dashboards for performance and capture from the EVs. If you are a power system engineers caring for the grid and looking into high adoption EVs pathways and its impact on the grid, again this course will give you the basics how it works for you to really build again higher level models and grid integrations. So all in all, I believe that this course will allow you to really understand the EVs as a system and tie up the customer requirements to all different subcomponents requirements, including batteries and chargers and motors, and then understand the overall EV performance. Thank you again. Thank you, everyone.